Hello, welcome to ANS Solver. This is the 10th question of the paper. So as you can see, there's the complex number u, which is given by -3 minus 2 root 10I, showing all necessary working, and without using the calculator, find the square roots, of u. Give your answers in the form of a plus ib, where the numbers a and b are exact, real and exact. Okay, so what we basically need to do is, we know that I have a plus ib the whole square because of square roots, correct? And I know in this expansion I'll get this as a square plus b square, which is something like this, plus 2 into a into ib. Agreed? So I'll get this basically as a square plus b square I square plus 2abi. Now you need to know that I square is equal to -1. Correct? Basic concept. So I'm going to write this as a square minus b square plus 2abi. Now what I simply do is I compare this with -3 minus 2 root 10I. Now I equate the real part to the real part. So the real part here is a square minus b square and -3. So I equate a square minus b square to -3, and I equate the imaginary part, which is 2ab, to minus 2 root 10. Now what I can simply do is I can basically write this as a equals to minus 2 root 10 over 2b, where I can simply cancel 2 and 2 to get a equals to minus root 10 over b. Got it? So now what I can simply do is I can equate the value of a, which is minus root 10 over b, in the place of a in this equation. So I can write this as minus root 10 over b the whole square minus b square equals to -3. So now I can basically write this as 10, because minus 1 the whole square is 1 and root 10 the whole square is 10. Okay, over b square minus b square equals to -3. So now when I cross multiply, or basically take the LCM, I can write this as 10 minus b raised to 4 over b square equals to -3. Got it? So this I can basically write as 10 minus b raised to 4, equals to -3b square, which now can be written as b raised to 4 minus 3b square minus 10 equals to 0. Rearranging everything to one side. Now what do I do? Now if you see, this is a quadratic. So I can say let b square be z. So I can write this as z square minus 3z minus 10 equals to 0. Now I know this is a quadratic to solve. So I have my formula, which is minus b plus minus the square root of b square minus 4ac over 2a. Agreed? Here my a is 1, which is the coefficient of z square. My b is -3 and my c is -10. So I can basically write this as minus of -3 plus minus the square root of -3 the whole square minus 4 into 1, sorry, not -1, into 1 into -10 over 2 into 1. So I can basically write this as 3 plus minus the square root of -3 the whole square is 9, and -4 into -10 is 40 over 2. So I can write this as 3 plus minus the square root of 49 over 2, which can basically be written as 3 plus or minus, okay, the square root of 49 is 7 over 2. So now I know this is z and I know z is b square. So I can say that b square is equal to 3 plus 7 over 2, or b square, okay, is equal to 3 minus 7 over 2. So now I can basically write this as b square equals to 10 over 2, which gives me my b basically as the root of the plus or minus 2 over 10 is 5. So I can write this as plus minus root 5. This I know cannot be solved, okay, because I get b square equals to minus 2 here, and a square root of a negative number is not possible. So I only focus on this, okay. Now the equation I have in mind is that a equals to minus root 10 over b. So I can say a equals to minus root 10 over b. So what I'll do first is I'll put plus root 5. So I get this as a equals to minus root 10 over root 5, which gives me my a basically as, when you solve on the calci, root 10 over root 5, you get your answer as root 2. So here you get minus root 2. And let's say when I put b as negative root 5, so I get this something like this. So I cancel this and I get a equals to root 2. So I can say in the a plus ib form, I have two equations with me, okay. My first equation I can simply say is minus 2, okay, plus root 5i, and the second equation I can state, okay, sorry, this is minus root 2, sorry, minus root 2, okay, and the second equation I can state is simply root 2, okay, minus root 5i. It can be denoted by a plus or minus, but yeah, this is basically the final answer of the question of part 1 of part A, sorry. So now we go to part B. On a sketch of an Argand diagram, shade the region whose points represent complex number z satisfying the inequalities here. Argument z, imaginary, okay, so there are three things which we need to satisfy here, where imaginary z denotes the imaginary part of the complex number z. So as you know, this is your imaginary part, this is your real part, sorry, this is your real part, sorry, I clicked on the up arrow by mistake. So let's focus on the circle first. I have z minus 3 minus I, which is less than equal to 3. So now you need to be very thorough with your concepts. You need to know the exact form of the circle. So here we take negative common. So we get 3 plus I, okay, with less than equal to 3. Got it? So now what we simply do is, we can simply write this as, I can say the real part here is 3, comma, the imaginary part here is 1. This I know is the radius. This is my argument and this is my imaginary. So what I can do is, I need to make a sketch. So I'll first make the coordinates, okay. So I'll get something like this, okay. So yeah, you just need to mark these before we start. So now see, first let us focus on the circle, which let's say is denoted by the blue pencil, okay. The blue pencil is the circle. So 3 comma 1 is my center. So 3 comma 1 I know lies somewhere here, is my center. My radius is 3. So my radius, I can say one point of my radius on my circle is here. another point is somewhere here. Okay, another point is somewhere here, 1, 2 and 3, and another point, let's say there was a 6 here, so it's here. Okay, so I can say this is basically my circle. Okay, I know my drawing is not that good, but yeah, now what I can simply do is I can take my green marker, okay, green pencil, and I can plot this. The argument of z should be more than equal to 1 over 4 pi. So argument of z, 1 over 4 pi, I know is something like a 45 degrees. So it's something like this. Okay, where I can say this is 1 over 4 pi. Got it? Now the last, okay, which I have the imaginary of z, which should be more than equal to 2. So I know that line passes through somewhere here. Okay, got it? Now what we basically need to do is we need to see the attraction. Like there's no term for this, but yeah, I call it attraction. Basically what we need to do is we need to see the equation satisfying signs. So here my circle needs to be less than 3, less than the radius. So the attraction here is inwards. Got it? Here my argument needs to be more than. So my attraction here is outwards again. And here finally I can say my imagine needs to be more than 2. That means this needs to be upwards. So if you see, the area satisfying the equation is simply here, the area in purple. Correct? This is the area satisfying all the equations. Correct? It's more than the imaginary, it's more than the argument, and it's less than the circle, less than the radius of the circle, which is 3. So yeah, this is how you plot. So I've used the different colors, so it's easy to understand the question.